In this video, we'll be looking at exponential functions. We will cover what shape the graph will take, how to graph an exponential function, understanding the symmetrical equivalent, as well as discussing asymptotes, domain, and range. After this video, you will be able to graph an equation like this, step by step, by using two methods and verifying your answer. The first exponential graph shape we'll discuss is y equals a to the power of x, where a can be any integer bigger than 1. With this equation, when your x gets bigger, your y will also get bigger. You can look at the equation and substitute values in for x to see that your y will also get larger. Thus, the graph will look like this, cutting the y-axis at 1. An asymptote is a line that a curve approaches as it heads towards infinity, but the curve never reaches it. In this case, the asymptote is y equals to 0. The domain is all the possible values for x for this equation. As you can see on the graph, x can be any number. Thus, x can be any real number. Or x is in the set negative infinity to positive infinity. And infinities aren't included, thus you have to use round brackets instead of square brackets. The range is all possible y values. And as you can see, because we have an asymptote, the y value never reaches 0 or any negative number. Thus, y will always be bigger than 0, or y is in the set 0 and positive infinity, both not included. We will look at domain and range again in the example. The next exponential function we're going to look at is y equals a to the power of minus x. You can also write it in fraction form because of the negative exponent. As your x increases, your y value decreases. Thus, your graph will look like this, cutting the x-axis at 1 yet again, and your asymptote will still be y equals 0. When you graph these two equations on the same axes, you can see that they are symmetrical, more specifically symmetrical about the y-axis. The last equation form we're going to look at before the example is the equation in the form y equals negative a to the power of x, with a being yet again an integer bigger than 1. Your graph cuts the y-axis at negative 1. As your x gets bigger, your y will decrease. Thus, your graph will look like this, with y equals 0 being your asymptote yet again. If you plot y equals 2 to the power of x and y equals negative 2 to the power of x on the same axes, you can see again that they are symmetrical, more specifically symmetrical about the x-axis. So, with all this knowledge, we can move on to the example. Graph the following equation. Y equals negative 2x to the power x plus 1 and then plus 2. Firstly, we're going to look at the table method. You start by choosing values for your x. I started mine with negative 2 all the way up to positive 2. To get your corresponding y values, you need to substitute your chosen x values into the equation. Here, f of minus 2 is 1.5 or 1.5. When your x is negative 1, then y is 1. When your x is 0, your y is also 0. When x is 1, then your y is negative 2. And lastly, when your x is 2, then your y is negative 6. Put all of these calculated values into your table, and now you have your coordinates for your graph. Plot these points and draw a curve to match. Don't forget about your asymptote. The plus 2 in the equation means that the asymptote will be at y equals 2. The domain is all real numbers because x can be anything, and your range is less than 2 because y can be anything as long as it's less than 2. Moving on to the second method, the parameters method, we will be breaking down the equation starting from simple equations and working up to the final equation. We start off with y equals 2 to the power of x, which we have covered earlier in this video, and it looks like this, cutting the y-axis at 1. Then we look at the negative before the first two and we graph y equals negative 2 to the power of x. Because of the negative, the graph reflects about the x-axis and thus will look like this. Building onto our equation, we now add the constant plus 2, which gives us y equals negative 2 to the power of x plus 2. The plus 2 just shifts the graph 2 units up. With y equals negative 2 to the power of x, it cuts the y-axis at negative 1. And since it moves 2 units up, the new equation cuts the y-axis at 1, because negative 1 plus 2 is 1. To get the x-axis intercept, you have to make the y 0, which will give you 0 equals negative 2 to the power of x plus 2. By inspection, you can see that x has to be 1. Because negative 2 to the power of 1 plus 2 is 0. Now our equation will take its final form. The plus 1 next to the x in the exponent means that the graph shifts 1 unit to the left. If it was x minus 2, then the graph will shift 2 units to the right. Because our previous graph cut the x-axis at 1, and now it has to shift 1 to the left, the final equation goes to the origin, or coordinate 0, 0. Don't forget about your asymptote, which is at y equals 2. The domain is all real numbers because x can be anything, and your range is less than 2 because y can be anything, as long as it's less than 2. Thank you for watching, and I hope you understand exponential graphs a bit better now. Good luck.